So we have learned linear regression with single variables and multiple variables and polynomial regression. And here's the question: how do we know like how good fit is our model? So basically, there are several ways to determine it. To determine the goodness of fit in the regression problems is popularly R-squared value, which is a coefficient of determination. And the definition of it is it's 1 minus RSS by TSS, where RSS is the sum of square of residuals, and TSS is the total sum of squares. So residual sum of squares is the sum of the square of the difference between the actual value and the predicted value. Total sum of squares is the summation of square of the actual value and the mean value. So what does this value mean? It can be as closer as it is 1, the better fit it is. So when we are fitting a data to a linear regression curve that is aligned, we want to be as close as 1. Now, how do we test different data? Let's do it in our data set. We will test two different data sets here. One is salaries.csv, which looks like this. You can see that it's not a good linear fit at all. So probably we should use polynomial fit, but we will use linear regression in it and try to test the R-squared value. And another one is salaries linear.csv. You can see that the value and the salary actually increases linearly with the level. So it should be a very good fit, right? So let's see how we code. Basically, our X value is the level and the Y value is the salary. And we apply the linear regression fit as we have seen in the previous lecture. And we plot them. We can see that the fit is not that good. The actual data are the dots. And the fitted line is this. You can see that most of the data points are not close to this. So the difference is, so there is difference between the actual data and the predicted curve. So when we calculate the R-squared value, it will be definitely less than 1, meaning that it's not a good linear fit. So R-squared is calculated in this way. We have X and Y, and we determine it by lean reg.score. So R-squared value is 0.66 here. So not that good of a fit. Let's test for the other one. It's salaries linear.csv, and it looks like that the level correlates very linearly with the salary. And the rest of this is the same. After we plot the actual data, X and Y, and predicted Y, we get this. You can see that all of the data points are actually very well fit with our predicted line, and we can actually calculate the R-squared value from here, and we can see that it's perfectly 1. It's perfectly 1 because all of the data set are actually matching. All the actual data are actually matching with the predicting curve. If some are outside, some were outside, it would show much less value than 1. So that's how you can quantify how well your linear regression model is working.